everyone. My name is Stefan Rentewitz. You probably know me already. I'm a professor here on RISC-V Board of Directors, and what led us to this panel is the discussion that you already also covered by the ChipsJU presentation, right? We have been active in a lot of R&D projects. There's a lot of foundational IP that has been created in the open source space, especially, but also beyond. But the question is, for the panel now, how can Europe be better engaged in RISC-V? And this, in my opinion, ranges a broader range from standardization activities up to commercial opportunities and picking them up. And for this, we think we brought four very good panelists together. The first one is Alexandra Kofali, who is from the EuroHPC. Thank you very much. So the second panelist is Christian Reitberger, who is a partner at Metabase Venture Capital. And the third one is Peter Gilder, the CEO of Antmicro, a European SME. Can you take the second one? Okay. And the last one you already saw in the session is Teresa Severo from BSC. Thank you very much. Yeah, so thank you very much for participating in the panel. Looking forward to it. It's a very broad discussion topic, as always. We would try to focus on a few topics that we discussed before, and would like to engage with you not only during the session, but also throughout the evening, once the thunderstorm is over and we can go to the social event. We will not have a round of introduction. I will just immediately jump in with a question. And Alexandra, you told me you joined the EuroHPC not too long ago. We learned about EuroHPC as the other joint undertaking, which at the moment has a very large initiative in RISC-V. Can you briefly describe what your role is as a program manager, project officer, sorry, and what your first impression was when you entered the space and saw RISC-V and Europe?
Okay, so hello everybody, thanks for having me. So yes, I joined less than a year ago, but EuroHPC is also 3 years old, so we are not that old anyway. So yeah, the role is project officer within the European Commission, but we call it program manager within the JU. So what I do is basically, let's say, the whole life cycle of the grants. So we start from drafting our work program and drafting the calls to run the evaluation of the grants and then negotiate with the consortium. We start the project, we monitor the project, we are there if something is problematic to align, realign, we do the amendments. So it doesn't mean that since the consortium has committed to something, that doesn't mean that this option is viable. Technologies change and goals shift, so we are there for that. So it's not okay, you committed to that, you have to deliver, no. So we monitor this, and then at the end we evaluate the project at the beginning. And when the project finishes already, we have something new coming up, so we try to keep a whole cycle of grants happening.
Mm-hmm. Yeah. And what is your impression about RISC-V when you learned about it?
So it's fun. I was very happy to see such a vibrant community. So I was not new to the concept of RISC-V, let's say, but it was the first project I started managing. But we don't only do RISC-V, right? We have two roadmaps. We have the RISC-V roadmap and the ARM roadmap, right? So I like the fact that it's open and there is a lot of community involvement and it's being built from the ground up.
Mm-hmm. Yeah. Okay, thank you very much. Christian, you're a partner in Metabase Ventures, and I learned you through your investment in CodaZip, which is a European company. What was your impression when you first engaged with RISC-V and learned about their activities and about the vision there?
Mm-hmm. Yeah, so we are indeed a deep tech investment fund that I run with a couple of partners. And in the semiconductor domain, we are very broadly engaged across the whole spectrum from, let's say, very fundamental manufacturing technology innovations to a couple of breakthrough architectural design innovations. And RISC-V, when it appeared on our radar screen, so to speak, some 5 or 6 years ago, I believe, was interesting as it was a different kind of innovation, an instruction set architecture innovation, which at first one could have asked, why do we need another ISA? But then, of course, there was this interesting confluence of, let's call it geopolitical factors and the really interesting triad competition arising and the need, we believe at least, for a European-controlled ESA, which can then be embedded in processes that can be globally exported and globally applied. On one hand. On the other hand, what we liked a lot was, on one hand, the openness, but then also the extendability and customizability, which led us to conclude, in our thinking, that we were probably not smart enough to pick the right RISC-V processor IP vendor, but rather pick somebody who provides the capabilities, if you want the design team in a box capability, to system vendors and to, of course, IDMs as well. And this then led to CodaZip, which is a very unique blend of EDA-based capabilities, plus, of course, great cores you can then design around and can then customize for your needs.
Mm-hmm. Thank you very much. Peter, you're the CEO of a European technology company, and you have a very long history in RISC-V, and in particular in open source. That's how we know each other. Can you speak about your current RISC-V engagement?
Yeah, so I actually did some research, and interestingly enough, exactly 10 years ago, in summer, like a little bit like maybe 2 months, it will be a perfect anniversary of when we actually, within the company, we heard about RISC-V. And it's a little bit of a, like both US and European story, because we heard about it from Andreas Olofsson, that is American, but he has Swedish roots, and we were doing a lot of things in Scandinavia, so we knew Andreas from before. He was running Adaptiva at the time, and he was very excited about RISC-V. We trusted his judgment, and so we got interested too. And then basically Berkeley, Krista and friends, they came to CERN the next year, and that's when we basically immediately joined RISC-V Foundation, because we felt, okay, this is the thing we were waiting for. So we've been involved in similar things before, but they never got enough momentum, and you could feel the momentum. So for us, it was kind of obvious. So there was this honeymoon phase when we felt, okay, this is like basically an open standard, it will happen. And then you could, so basically we started going to US, because most of the RISC-V Foundation activities at that point were in US. So in US, this excitement was building up. It was happening within Google, within Western Digital, within basically well-known established companies. In Europe, not so much at the beginning, so you could feel a little bit of a detachment, but obviously we're living in a bubble. So from our perspective, RISC-V was obvious, more or less, let's say, 7 years ago, I would probably, and we did a huge bet. We basically started doing more and more RISC-V, and the bet was right. I think even the question whether RISC-V will be successful in Europe is not a question anymore. It is already successful. It already happened. I think it's a matter of time before all companies understand that RISC-V is here to stay, and not doing it is just loss. So in this sense, I think that happened. So it's a great journey. I think it's great. It is 10th anniversary.
It's a matter of time later. Teresa, you're a senior researcher at BSc. You presented earlier a little bit from your lab. You've been engaged in various research projects before, and you're now leading this LUCA, it's called, right? A special research lab. Can you say a little bit about how it differentiates from other projects that you have, and what the role of it is?
Yeah, so I started BSc like 4 years ago, and I was working as a hardware coordinator of the MIP project. So my role there was to coordinate all the hardware teams to be sure that they were aligned with the objectives of the project, so simulation, RTL, FPGA, verification, FPGA. And when that finished, we start with LOCA, which is Laboratory for Open Computer Architecture. It's within a national project called, which is Severo Ochoa. And the idea here is to foster collaboration, but also not only outside with BSc with others, but also internally at PSC and using RISC-V as a vehicle for this, because we are running many projects. We have grown too much. We have grown very fast, let's say, and now we need this kind of figure to organize what we are doing and doing in a more efficient way. No better, but in a more efficient way. So that's more or less what I'm doing now, and also engaging with the RISC-V communities. That's the reason why I'm here, participating in the organization and the summit, also engaging with the SIG HPC in RISC-V International, so trying to also gain knowledge on my side, but also to connect with the community there.
Thank you very much. I want to speak a little bit about public funding because it plays an important role. We saw the presentation by ShipCU before, and Georgi touched on a couple of topics there, and you are from EuroHPC. I heard, because I'm in there, about this framework partnership agreement on RISC-V that you have granted this year, right? Which is leading to a research project now, which is a lot of money for RISC-V in HPC. Can you say a few words about it?
Yes, correction, we don't have one FPA. We'll have two FPAs because the European Processor Initiative is also an FPA.
I see, right.
So basically we have these umbrellas that we call them framework partnership agreements. I think more or less everybody here knows about it, but for the very few that they don't know it, is that we have this umbrella where we lock a consortium for that they are going to work together for like 6 years or 9 years, let's say. And there, within that, we grant smaller grants, and these we call them specific grant agreements. And then these are smaller actions that are specifically linked to dedicated funding and to a specific call. So we have the European Processor Initiative that is on the second phase now. And now we are starting the RISC-V one, which I cannot go into too many details because we haven't formally signed yet, but it is a very big RISC-V initiative that covers the whole stack. It covers processors, accelerators, the software component, pilots, new benchmarks, the whole software stack, and it's a very big consortium of 50 partners, more or less.
Interesting.
Yeah.
And what is the expected outcome?
Excellent question. At EuroHPC, what do? We have two big branches, let's say. We have the procurement branch where they casually buy supercomputers. We have so far 9, and we have the calls, the grants, the research and innovation team, where we make the calls. And then with the RISC-V, basically the ultimate goal is to make processors and accelerators that will be ready to be put into future supercomputers. So a very big, a very risky initiative, but we are committed to make it happen. We have a very, very, very strict timeline to achieve that. We have a very specific roadmap, and we are very excited.
So the ambition is that they are also, in the end, the results more or less transfer to the other branch, which is the procurement, which is
So
important.
eventually, the ultimate goal in the future, it is that these will be chips that they can get into future supercomputers.
Okay.
Now, where, what, will they be ready? Is up to you to design them, so let's see.
Thank you very much. Christian, you're not, I think, involved at Codazip at the operational basis, but I know that they are quite involved in those funding projects. Can you say a few words? I know you're in an IPSA too. This is a puzzle piece in Europe, right? You can't really be active without it, I assume.
Yeah. Yeah, so I've been in this investing circus for 25 years now and have done my first semiconductor investment in 2000, so 24 years ago. And one thing has not changed, which is capital availability for semiconductor startups in Europe as compared to the US and especially also China is not on the same level, is not on par. But this must not mean that we lower our ambitions. This cannot mean that we are baking smaller cookies, as they would say in German. We need to strive for globally competitive breakthrough products. So how do we solve that? Well, one option would be customer revenues, which is the best funding source of all. Well, European customers are much more conservative than the typical US and Chinese counterparts, so that is not the solution. So quite frankly, the only way that we can operate in that sector is by tapping into, quote, public support, unquote, and that has two instantiations. One is what the European Innovation Council has been building up over the last 3-4 years, which is a remarkable achievement of one of the most active deep tech investors, which is invested in, I think, 8 of our 42 portfolio companies at the moment. And we are talking many tens of millions that have been provided by that means. And it's not a grant, it is an investment. So the EIC will make money with those investments, so all good. But that would also not suffice, especially if you have a more ambitious roadmap, as Codasyp, for example, does. There is a need for additional grant funding, and the CHIPS Act and its implementations in various instruments like IPCEI, but also in the joint undertakings, is essential to be able to get these companies funded. We know typically how to get, let's call it maybe 100 plus minus million of equity together. But some of these more ambitious bets need 200. And what do? I can, of course, go to China, and they would immediately give me the money. Maybe that is not the ideal solution, especially if we talk about European tech sovereignty. And this is where the joint undertakings come in, and this is where, in the specific case of Codasyp and IPCEI, grant came in, and maybe also more from your side.
Yeah.
Thank you very much. Peter, you have bootstrapped the company essentially, right? But you're also participating occasionally in publicly funded projects, right?
Yeah. So we're part of Tristan, and basically, I think at any given moment we were part of a European Union project, and we're doing something with RISC-V the moment we heard about it. So we're obviously trying to leverage that. But I agree with Christian that the amount of generally funding, and I think both in terms of public funding, but also like types of VC funding that exists on the market. The reason we're not a company that was started with unusual, like in America, when I tell the story of Antmicro, it's an unusual story of a bootstrapped company. That's not normal there. The normal way would be to get money from VC. Whereas in Europe, that's how companies start. And I think that's a very hard way to actually build, for example, a semiconductor company. So we're a software company, so it's easier because we started with software and we moved into hardware, so we kind of bootstrapped our way into basically, so now we do silicon development or parts of it, but obviously we haven't started with that. I don't think we would be successful if we start with that because we would need a lot of investment that basically we had to earn and reinvest. So I think that's one missing component in Europe to actually solve this problem. I think that the amounts, like the programs are defined in the correct way, but the amounts of funding are missing as zero, and not at the beginning. So that's definitely a challenge, but I also think that that's a solvable problem within private industry. I mean, funding doesn't have to come from public sources. It can come from companies that have to understand that investment has to be made.
Mm. So what I take away is that you essentially say there's a lot of interesting funding publicly available, and the programs per se are right? And
so, for example, most of our funding just comes from customers.
Yeah.
Like we
best funding.
Yeah.
A revenue stream. Teresa, I know also from my personal life, private and professional life, my personal life fortunately not, that you have to balance between regional, national, European funding and all the different complexities there. Can you say a few words? Like, also for us, private funding is the sweetest source of money, right? But how do you see the current funding landscape in RISC-V?
So, well, for us as a public institution, the public money is very important. Actually, we sustain because of that. So we live, let's say, as an institution, thanks to the society, to all of us, basically. So we have to be sure that we use that money in an appropriate way. So we revert something to the society. So that's one of the nice things of BSC in this case, that we have these application departments that run models that are used for example, for weather forecast or for solving problems to the society, and then we also engage with the society. And also we use this public funding as a mechanism to educate the future researchers or future engineers, because you don't know how life changes, so you're going to start as a researcher and then move to the industry and then you don't do too much research, or the other way around. So we think public funding is important. We, of course, also engage with, we collaborate also with industries, but always under this research framework. So that's something that we have to be clear and keep clear to everyone, because if we want PhD students, they need to publish as researchers, so we need to keep things as open as possible.
Alexander, one thing I noticed, like the FPA is very large, right? It's a very large consortium, 50 people. I'm in Isolde, it's also a large consortium, and we saw like each of them has one consortium. That's an observation I have. There seems to be like a concentration on very large consortia. Is this something intended, or?
The thing is that also there is a lot of money around it. So yes, it's a consortium of more than 30 partners, but only the first phase is 250 million almost. So it is not, we don't say, okay, we need 40 beneficiaries, but that's eventually what happens because the call is very big. There are too many things that need to be addressed. So the response from the community is this big agreement. And also, it's an indication that Europe collaborates as well, right? It's not always the 5 big players that they come together and they claim 250 million. Is also a bit of SMEs, a bit of big names, big companies, and a lot of research institutions. So it's a mix and match.
Thank you very much. I think you already touched, like Christian and Peter, especially like the public funding is ideally not your revenue stream, right? And I think there's a lot of opportunities. I believe in RISC-V opportunities for Europe. If you, Christian, look at CodaZip, right, and other IP companies, I would assume what you're looking at Europe right now is not a thriving market. Can you say a few words about your thoughts about the European application folks, etc.?
Yeah, so the good news is that Europe has an enormous amount of potential customers for all kinds of RISC-V-based technologies. We have globally leading systems companies in aviation, in defense, in industrial automation, in, of course, automotive and the whole supply chain. So we have globally leading systems companies there, number one. Number two, I think we have the growing realization that the best companies in those sectors, as translated into market cap, do their own chip designs. A Tesla and Apple derive a large fraction of the differentiation and thus also the market capitalization from owning their own high-end designs. So that realization that you might not just win by buying off-the-shelf ARM or even off-the-shelf standard processors is not the answer to the differentiation question. There are also other aspects like safety, like supply chain control, like well, all defense-related aspects of knowing what is in your SoC, really, which would imply that getting closer to owning your chip design is a good idea. Now, this top management realization may be there. It has by far not transpired down to the ranks that actually then decide on which basis to realize a new product introduction. There's I observe significant disconnect still between the political C-suite realization, oh yes, we need to do something here, and the folks who actually need to do the job then, who say, oh, please, blah, don't come with any new tool chain, please, no new ISA, no, I won't get fired for buying ARM. That is the then typical reaction. And we really need to break through this. We really need to make this transmission wheel happen and convince the people who actually need to do the job then that RISC-V is a safe option if you do it right. It does not get you fired, and it does deliver the performance that you need to differentiate.
Mm-hmm. Okay, interesting. Peter, you told me in the preparation that I think it's the majority of your business you're actually doing in the US. Can you say a few words why that is in your opinion?
Yeah, so it's not by design. And when we started, let's say that obviously you treat US as one of the markets, but definitely you think about Europe, like that's closer, that should be easier, right? You don't have to fly over an ocean to meet. So it would be natural that you can and the market is very big, definitely. There's a lot of potential customers, so it should work great. I think there is a difference, and I think that's a gap that we have to fill in Europe, that basically doing business in America, especially in this innovative things where you're actually not doing something conservative that you've been doing for 20 years, but you're doing something new, it's much easier to basically find customers, including those established companies that you would think that they would be conservative, but they're not. They actually invest in new things, then they are not afraid to fail, because not all of those things succeed, but they are not afraid to bet on a new thing like RISC-V. So within RISC-V, well, even if it was brand new, you had those big players in America. And in Europe, it took more time to get those big players to actually invest a little bit. And you could feel hesitation in Europe, whereas in America, there was excitement. So I think we're lacking a little bit of this excitement. And that makes this type of the new thing harder. Now it's easier, because now I think it's battle proven. It's no longer a question if it's a good idea. So now I think, so now we actually see more traction, but definitely it's easier to find normal customers in America for things like RISC-V. But I think it's broader. Like, we do a lot of open source, and the same stories within, for example, operating systems. We started with Linux, and Linux, like, reactions here were always like, oh, we shouldn't put Linux in a car. And we say, well, obviously it will end up in a car. And I think, and it happened, obviously, but before it happened, you got this, like, a lot of companies just saying no. And same thing, we're heavily involved in an operating system called Zephyr, where we actually do RISC-V, and it's a similar thing, that there is a bigger barrier here, that I think we have to work on that to be more excited about new things.
Mm-hmm. So yeah, I think to take the positive spin, right, like currently we can see also in this event, right, we have a lot more participation from companies that actually venture going into RISC-V, right, and doing more commercial activity there. And we have seen, like, I think historically, like, R&D was very strong in Europe. Like, we had, like, the ETH and Bologna team, right, doing a lot of groundwork that now ended up in the ChipStone undertaking, for example. Teresa, when you do our research or projects, how do you work with industry on the transfer? Because that's important now, right? Like, if I look, like, I saw the graph of Georgi, like, now the next step is we need to get it into industry, right?
So, well, as researchers, we have to think on ideas. Even if they are crazy ideas, we have to analyze how to make that happen. So we need to understand, okay, is this idea good enough or innovative enough to be a patent, for example? Or could we license this in a way that can be used for many people in the community, so open source, or dual licensing if you want an exploitation? So we have to think on these things before we start on the hands-on. And later on, we can start collaborating with, well, other research institutions or other companies and see if this makes more sense. So sometimes we are very, let's say, crazy and say, hey, everything is open source, and let's publish everything. And let you say, okay, now I've published this, and I cannot work on a patent because I've already published my own work or something like that.
Provisional application next time.
So we are still working on that, but it's part of the process. So we need to have a great idea. We have to discuss internally. We have to also participate in the community. So many things, even if they are not perfect, should be open source, because it's a way that we can also get feedback from the community, and we also can take advantage of what the community is publishing. So on hardware, we have been doing that. We have a repository with plenty of IPs. On the software, the same. But we also want to, I don't know, have future entrepreneurs. So we also have to think on sometimes, let's license this, or licenses or whatever, so you can create your own spin-off and then, grow and participate as part of the ecosystem, but in a different way.
And it's interesting, maybe highlighting that you should get up early tomorrow to see Frank's talk from ETH, where we speak a little bit about the business model around academic spillover, I think. And speaking of spillover, like that's my favorite word that I learned 2 years ago when I worked with the German government, and they always ask for spillover to the automotive industry. Alexander, like how do you actually track this? Like, it seems very abstract to me, spillover, and it's always like on the source, right? Everyone says, oh, there needs to be spillover in the end. How do you track, and maybe also adding like the chips you saw like everything is building on each other. The same is with EPI and the FPA now, right? How do you track and really make sure that they actually build on each other and we see the spillover and transfer to industry?
So we have different methodologies to do it. So as I said, the first is the framework partnership agreement. So there we specifically track that the consortium will work together and then it will go into transfer. The other is as the ChipsJU is doing, also we make them sign specific agreements that they are going to collaborate. So we make sure that one activity will transfer to another action that is basically, let's say, higher TRL, more industrially driven. So this is the second thing. The third thing is that when we evaluate a grant, we make sure that also the experts that we hire also make sure that they evaluate also the spillover. Okay, how can we make sure that this IP will get transferred to another activity? Of course, we make sure that also there is no double funding involved. So there is some technology transference, but we should not two entities are allowed to do the same thing at the same time. Okay, fine. And then, of course, we have our internal events that we bring everybody together, and we make sure that everybody knows what is happening in the industry, so then we enable the community to move on and collaborate also beyond our actions. Yeah.
Awesome, thank you. Yeah, I'm really looking forward to this really playing out, because to me it feels like now is the time that we need to really get this right. Right?
Absolutely, yeah. And keep in mind that the JU is a high TRL activity. So what we do is, the goal is that it is almost a product. So we do tape outs. Only the CHIPS projects have around like 10 tape outs in total. Yeah. So we don't do just we don't do research. We don't do research papers. We enable the community to design products.
Mm-hmm. Yeah.
Stefan,
yes.
May I ask something?
Yeah, of course.
It's
the panel.
Don't you think that sometimes when we prepare a call that we are excessively optimistic? I mean, when we think on Harvard, for example, we set a very high expectations. And of course, working with the large consortiums, coordinate that is very difficult. Delays happens, problems happens. So do you think there would be a way to be, I mean, the problem is if you don't create high expectations on the call, you don't get a call. But if you are more realistic, you are out. So is there any way that we could balance these, some mechanism to learn from the past experience and try to adjust this a little bit?
Yeah. So when you submit a proposal with a JU, let's take it the other way. When you submit a proposal with the commission, usually we can have hundreds of applicants. Mm-hmm. So our proposals have less competition. And also our proposals have experts that know very well the market. So if you are very unrealistic, you have less chances eventually to get funded. So it's better to be more realistic, and then you can, of course, you can overpromise. yes, this can still happen, but it's better to be more realistic and say, okay, we propose that this will happen and then this can happen. If you come to me and you say that in 2 years I will produce 2 accelerators in 2 nanometers fabricated in Europe, then I will say, yeah, this is science fiction and that's a different career path. So let's say we can understand that up to a specific level it's a bit unrealistic, okay, that's fine, but too unrealistic, you have less chance of getting funded. That's how we see it at the JU, right? Mm-hmm. Yeah. Did this help?
Yeah.
Publicly, sir?
More or less. We can discuss later.
You can follow up during the social event, yeah. It's the best opportunity to ask about this. I want to close with one topic that I think, like many people from outside of Europe, probably don't see that much of video, I'm not really sure, but when I asked you, Peter, to be on a panel, and you asked me what's the topic, and I told you it's about how can Europe engage better in RISC-V, you said the first issue is that there's no one Europe, right? Like there's no Europe brand compared to other hemispheres, right? There's no really simple solution to this. It's a political topic, it's a societal problem. But what do you see, like, especially in our field, you have to be, like, you have to think global, but also you have to think in terms of sovereignty as one continent.
Yeah. So obviously it's an exaggeration. So definitely European Union is basically somewhat leveling the playing field and creating a global market, but it's a much more complicated market than US. So basically you can clearly see that especially from a perspective of, like, if you want to sell to America, you just sell to America. There's no special thing you have to do if you want to sell stuff in Texas. Basically almost not look at where the company is coming from, you just check the country. In Europe, I think that's the goal, but I think we're still struggling to really build it. I mean, in some, I think, spaces it was successful, but I think in some spaces it's just crucial. Like, it's impossible to have a special chip that is only for one country. I mean, you need a big market for it, so it doesn't make sense to spend. It might make sense for certain things that are easy to make, and it's, you know, you don't want to transport them, so then you have a local, local grocery market, but not necessarily a local chip market. But I do think that we still struggle, and it's, you get this. I remember when we started the company, and you basically look for, like, how to run a company, and you hear that, oh, if you want to sell something in this country, you should open something locally, employ a local person that speaks the local language, etc. That's not a viable solution in Europe. You can't be a company that speaks every single small language in a small country. It doesn't make sense. So in chip making, I do think that's an international market. I think even saying that there is just European market is simplifying it. I do think that there is a global market, and I do think that Europe has to be a player, and only Europe as a unity can be a player.
Yeah, and I think this was also touched before, right? We're not talking about, when we talk about sovereignty, it's not about only thinking about the European market, right? We have to have European companies in a global market. But Christian, I remember when we talked for the first time a year ago, you spoke about Codazip as a pan-European company. Can you elaborate a bit what you mean by that and how you see the vision there?
Yeah, it's multifaceted pan-European. On the basic level, it is about recruiting. So how do you build a large team of, on one hand, process design experts, and on the other hand, EDA toolchain experts. If you want to do that in one city somewhere in Europe, you are doomed to fail because you will not get a critical mass of folks together. So you have to hire on a pan-European basis, and people also don't really want to move anymore. So per definition, you end up in a multi-site situation where different skill sets are then allocated in different sites. So it has a recruiting component to it, which the point in time when you could hire more than 200 people in one place in semiconductors in Europe is long gone. That doesn't happen anymore. Number one. Number two, yes, of course, this national level pops up when we ask for grant support because grant support is often being funneled through national agencies, and therefore there is national content being required in one way or the other, and that then sometimes makes it difficult to fit into the right box at the right time over the right timeline. I think we can handle that from a certain critical size on, which more than 100 people is certainly already critical size. And thirdly, I totally agree with you. The customers we sell into are global players anyways, and that again is the big advantage of Europe, that we have a plethora of global players in at least 5 very different verticals. It is not only about the next NVIDIA killer. It is not only about the next even more throughput token per or tera token per second LLM implementation. It's much more. It is from embedded to application. It is from defense to automotive. It is, and that's fantastic. Also because funding is not zooming in on this one machine learning application use case, which then is funded each with players that raise 500 billion per pop in the US and then fight to the death with each other. I think that it is an advantage to be more heterogeneous. European advantage.
I see. Alexander, you briefly comment, but you don't have to.
Okay.
I know that's like the single brand, as you already said, Christian, right? We always have national co-funding, and you're in a lot of discussions with the national authorities. Can you say a few words, like how this works out and how we can make, maybe in the long term, have a vision about like that you don't have to make every 27 countries happy with your funding?
Yeah, so luckily this is a policy question. So at the JU we don't do policy, we
That's
just
good.
implement it. So this is, luckily it's not our problem to solve, it's just we take advantage of this kind of a single brand of the European umbrella, and then of course we have to tap into the national funding due to our regulation, right? Because we have whatever we put then in as Europe, the countries then have to match. So this is good and bad. The bad is that for each entity that wants to participate in our actions, then they also individually have to make sure that they will find national funding, which is very problematic, okay, and very complicated. Fine. But from the other point of view, then this means that we have participation from many countries. And then this is, since we are also here with RISC-V, a ground-up activity, we need participation from many countries, and then we make this, this big brand that we don't address just one country, we address Europe as a whole, and then we just win. Did this cover?
Thank you very much. Yes, it's a good start for discussion. And we don't have much time left for questions from the audience, but the reason we scheduled this panel right before the social event is that we hope to spark some discussions there about the topics that we touched on and others. And Alexander had the great idea to end the panel with questions to the audience that you can discuss on your trip on the subway or at the venue, and you can engage with other participants or also with the panelists. Maybe start with you, Alexander. What's your question to the audience that burns under your nails?
Okay, so my question is, what do you think, like objectively you think will fail in RISC-V, and what do you do to mitigate it? So if you have answers on future failures, come to me, and from the complete opposite, what would you like to see happen in Europe on RISC-V that doesn't exist? Santa Claus, come.
Well, that's a call for action for tonight. Christian, what about you?
I have a probably more sociological question to bring up, which is, yes, this room is full of competitors. There are very few customers in here, but all vendors competing with each other. Let us not forget our RISC-V competition is not the other company, the other booth next to you. Our competition is Inaction or ARM or a CISC architecture out there. So my question to you is, can we somehow achieve, maybe via conferences like this or industrial associations like this, sharing of success examples where you have industrialized in high volume one of your solutions and are allowed actually to cite it and to quote it and to show the custom example. Because I believe showing successes, large-scale RISC-V deployments is what will reduce anxiety and maybe increase FOMO by some of the European players who have not yet really engaged. So my question to you is, sharing success examples very publicly, how do we do that?
Thank you. Peter.
Yeah, so it's. I think it's a little bit of a challenge, but I will ask the question anyway. So I do think that this lack of excitement, as I defined it, in, let's put it very narrowly, in computer architectures, is a problem that we have to fix. And the question is, how can we solve it on a even university level? That people that graduate from universities are actually excited about creating new ISAs, about adding things to it, about open source within silicon industry. Because we still feel it, for example, in recruiting, like a lot of people actually get their first contact with RISC-V within the company. It's still, and I do think that this crowd is an exception. So this question is maybe how to encourage others, because here, convinced people already here, but there is, I tried to check how many universities in Europe there are, and you can't find the answer, but I guess it's like thousands of technical universities, and only a handful is here. The question is, where are the rest, and why they're not here, and how can we fix it so that we get enough engineers to actually make this happen in Europe?
Oh, thank you. Some applause already. Teresa, what about you?
But just a simple question. Why European people doesn't participate too much in the standardization of RISC-V? I mean, there are plenty of groups, technical groups, SIG groups, and RISC-V International. All of you are engaged with RISC-V. Some of you participate and actually lead some of the technical groups, but it's not just about leading, it's about participating. So if we want Europe be a reference, we need people participating from Europe in those groups to understand, because you understand what are your needs as users, but also as industry, as So we need this voice, and we need your push. So why you don't participate so much?
Thank you. So I think that's good food for thought and discussions. Let's thank the panelists.